Hello, I'm Vin Mack. If you're a farmer, agribusiness operator, or value chain coach, you know that harvesting the crop is only half the battle. The next step, handling, storing, transporting, and processing the produce, determines how much value you actually capture. Today, we're going to explore 20 post-harvest technologies that you can adopt to reduce losses, improve quality, and boost income. Whether you operate in Ghana, Africa, or anywhere globally, there's something in this list for you. Let's get started. Why post-harvest matters. When crops are harvested, they immediately begin to change. Moisture loss, bruising, exposure to pests, inadequate cooling, and transport can all reduce quality. At the heart of post-harvest management is the goal to retain the appearance, flavor, texture, and nutritive value of produce. Source: FAO. According to research, key stages include cleaning and sorting, packaging, cooling or storage, transport, and processing. Source: via.com. If you don't focus on post-harvest, you may lose a large share of your harvest to spoilage, pests, or quality downgrade. That means income lost. So investing in the right technologies and practices makes strong business sense. Key stages of the post-harvest chain. Before diving into the 20 specific technologies, let's quickly review the key stages you need to think about. Cleaning and sorting, removing dirt, debris, and damaged pieces. If you skip this, you store bad quality. Cooling/rapid pre-cooling, lowering field temperature to slow respiration, moisture loss, and microbial growth. Source: Urban Agriculture. Storage and packaging, choosing the right storage environment or packaging so produce stays fresh. Source: Science Direct. Transport and logistics, getting produce to market while maintaining quality. Processing/value addition, converting or cleaning produce so it has a greater shelf life or value. At each of these stages, technologies enable you to step up from basic to value-oriented. The 20 post-harvest technologies. Now let's run through the 20 technologies. I'll give a short description, how it works, and how you might apply it. Hermetic storage bags, these are airtight bags or containers that restrict oxygen and thus inhibit insects and spoilage in grain storage. One example, the Purdue Improved Crop Storage, PICS, bags used in Africa. Source: Wikipedia. Controlled atmosphere storage, modifying the gas composition, oxygen, carbon dioxide, in storage to slow down respiration and aging. Source: via.com. Cold chain pre-cooling/rapid cooling units, installing a unit to bring field harvested produce temperature down quickly so that deterioration slows. Source: Urban Agriculture. Smart humidity and temperature controlled storerooms, using sensors plus thermostat/hygrostat to maintain ideal storage conditions. Edible coatings/natural preservatives, applying a thin edible film, e.g., chitosan, wax, on fruits/vegetables to reduce moisture loss and delay ripening. Source: via.com. Mechanical sorting and grading machines, machines that sort produce by size, weight, color, or defect to improve quality and reduce labor. Modified atmosphere packaging, MAP, packaging produce with a modified air composition, sometimes vacuum, to extend shelf life. Source: Science Direct. Solar or biomass-driven drying systems, especially for grains, fruits, using solar tunnels, biomass heaters for efficient drying and reduced spoilage. IoT sensors and monitoring systems, using internet-connected sensors to monitor storage/transport conditions in real time, temperature, humidity, gas, and send alerts. You'll see increasing research in this area. Source: Frontiers. Vacuum cooling/hydro cooling systems, for leafy greens or vegetables that wilt, removing heat quickly by vacuum or water immersion. Cold chain transport vehicles/refrigerated trucks, ensuring produce is kept at the required temperature while being moved to market. Value addition processing units, small scale, for example, slicing, blanching, and dehydrating fruits or vegetables locally so you capture more value. Source: Agriculture Institute. Packaging innovations, biodegradable, compostable, plus tamper-proof packages, to protect produce, reduce waste, meet buyer expectations. traceability and digital quality systems, QR codes, blockchain, or digital records so buyers can see how the produce was handled post-harvest and quality assured. Cold storage modular units for smallholders, low-cost cold rooms or modular units that smallholder cooperatives can use, rather than only large farms. Mechanical cleaning/removing field debris/washing systems, simple but effective, removing soil, leaves, stones before storage or transport to reduce rot. Source: small farms. Shock-free harvest handling equipment, design of crates, conveyors, or handling systems to reduce bruising and physical damage during harvest and transport. Source: urban agriculture. Solar-powered fans/aeration systems in storage, to keep air moving and reduce heat/humidity buildup in stored grain or produce. Smart inventory and first-in first-out (FIFO) management software for cooperatives, tracking batches, reducing spoilage by better scheduling of sales or processing. AI/deep learning sorting and defect detection systems, technologies that can inspect fruits/vegetables for defects using cameras and software, and sort them automatically. Research in this area is growing. Source: AR14. How to choose and apply the right technologies. Now that you've seen the 20 technologies, how do you pick the ones right for you? Here are 5 criteria. Scale: are you a single smallholder, a group/co-op, or a commercial farm? Some technologies are better for commercial scale, others for small scale. Crop type and value chain: is it grain, fruit, vegetable, or highly perishable produce? The shelf life and risk profile differ. Local context and climate: high temperature/humidity regions will need stronger cooling/ventilation solutions. Cost versus benefit: the capital and recurring cost of the technology versus the expected reduction in losses or increased value. Connectivity and maintenance: do you have technical support, power supply, and internet for sensors? Simple solutions may sometimes trump high-tech if support is weak. I encourage you to start with 1 or 2 manageable technologies, evaluate impact, then scale up. Emerging trends and future outlook. Looking ahead, several key trends will shape post-harvest technologies. Internet of Things, IoT, and real-time monitoring in storage and transport. Artificial intelligence, AI for quality control, defect detection, and sorting. Frontiers. Sustainability and circular economy, biodegradable packaging, reducing energy use in storage, upcycling waste. Digital value chains, traceability, producer records, connecting to market via apps, reducing middlemen. Customized small-scale modular systems for smallholder adoption, rather than large industrial. As a business coach and agribusiness mentor, I believe the greatest opportunities lie where you combine good agronomic practices, smart post-harvest handling, and value chain linkages. Conclusion. To recap, post-harvest management is not a cost center, it's a profit center. By using the right technologies and processes, you can reduce losses, maintain quality, extend shelf life, and gain more income. Pick one technology from the list, evaluate it in your context, track the results, and build from there. If you found this video useful, please like, share, and subscribe. Leave a comment below, which post-harvest technology will you adopt first and why? I'd love to hear your plans and help you get started. Thanks for watching, I'm Vin Mac, and I'll see you in the next video where we dig deeper into agribusiness value chains and coaching for farmers. Let's make your farm and your business thrive.